we look at physics for starters. Physics for starters. Physics is the study of natural phenomena at its most fundamental level. Physics is the study of natural phenomena at its most fundamental level. It is concerned with matter and energy. In physics, we deal basically with matter and energy and the relationship between them. So we look at matters, we look at energy, and we look at the relationship between the matter and energy. The effect of physics can be felt in all areas of human activities. We can see physics, we practice physics, we demonstrate it in every area of human activities. For example, the clinical thermometer used to take our temperature is part of it. X-ray machine used for taking X-ray. The bicycle we ride, motor car, camera, radio and television are a few of the many inventions and discoveries of man which requires a knowledge of physics for their understanding. So all these items and many others requires the knowledge of physics and the discovery of physics, and we need which give us the required knowledge of physics for them to for their understanding. So we need a brief knowledge in physics to understand the modality and the way all this item operates. Many natural phenomena, such as the eclipse, either of the sun or the moon, the rainfall, thunder, and lightning, also find explanation in physical principles. So these natural phenomena can also be explained by some fundamental principles of physics. Eclipse, rain, thunder, lightning, and many others can be explained through the process and the principle of physics. We look at measurements. Many simple observations and experiments in science can be made without any special measuring instruments. However, careful and accurate measurement is usually required in physics. In physics, most of the activities we do there are measured, and that would lead us to units. Under the unit, we have two groups of units. We have the fundamental quantities and the derived quantities. Fundamental quantities and derived quantities. Physical quantities are often divided into fundamental quantities and derived quantities. Length, mass, and time are among the fundamental quantities, because any other mechanical quantities can be expressed in terms of these three quantities only. So their fundamentals, length, mass, and time are fundamental quantities. Can you repeat this after me? Length, mass, and time are among the fundamental quantities, basically because many other mechanical quantities can be expressed in terms of these three quantities. However, another fundamental quantity is needed for electrical quantity, and this is usually chosen to be the electrical currents. A unit has to be determined. A unit has to be defined before any kind of measurements can be made, and that will lead us to the standard units, SI units, the standard unit, SI units, the standard units, SI units, and like we said, we have the basic three units are called the SI units. In this system, length is measured in meters, mass is measured in kilograms, and time is measured in time. So those are the standard units. I repeat, length is measured in meters, mass is measured in kilograms, and time is measured in seconds. So this SI unit is meter, kilogram, and seconds. Meter, kilogram, and seconds. The units of area and volume are derived from the unit of length. So those are derived. Derived units are gotten from the standard or the fundamental units. They are gotten from the fundamental units. They are derived from the fundamental units. Now let's go to standard physical quantity. Standard physical quantity. Standard physical quantity. We have the following as standard physical quantity. Like we said at the beginning, standard physical quantity, we mentioned the first three: length, meter, mass, kilogram, time, seconds. We have some other ones like temperature in Kelvin, frequency in hertz, current in ampere, charges in coulombs, force in Newton, work or energy in joules, power in watts, electrical potential in volts, resistance ohms, capacity in farad, inductance in Henry, and magnetic flux in Weber. I repeat, length. The unit of length is meter. The unit of mass is kilogram. The unit of time is seconds. The unit of temperature is Kelvin. Unit of frequency is hertz. Unit of current is ampere. Unit of charge is coulombs. Unit of force is Newton. Unit of work or energy is joules. Unit of power is watts. Unit of electric potential is volts. Unit of resistance is ohms. Unit of capacitance is farad. Unit of inductance is Henry. And the unit of magnetic flux is Weber. Standard. The measurement of any physical quantity involves a comparison between that quantity and a standard. Thus, masses are compared with a standard mass and time against a standard time. These standards are usually kept in the natural laboratories of certain countries of the world. Reproduction of this standard are then made available for general use. Standard units. Standard units have usually been chosen so that a unit is a convention or convenient magnitude for everyday use. Among these units, we shall be looking at some of the examples later. Then we have measuring instruments. Let's measure a few instruments and what they are used for. For instance, the meter for length, we have a meter rule. The meter rule is often used to measure the distance of a few centimeters to some meters. Distance of few centimeters to meters, that is meter rule. And we also have the vena caliper, which is used for the measurement of an accurate greater than 1 millimeter. The vena caliper may be used to measure It's mostly used to measure distance in diameter of a cube. So used to measure diameter of objects. We also have the micrometer screw gauge. Micrometer screw gauge. This is another device for measuring small distance. It is capable of measuring accurately to 1/100th of a millimeter. That is the microscope gauge. So these are the few things we're going to check or going to discuss in this first part. But let me mention another instrument for time. For time, we have some instrument for measuring time. Of course, we have the stopwatch or the clock, the stop clock or the stopwatch for measuring time. Then for measuring mass, we have chemical balance, weighing balance, chemical balance and weighing balance for measuring mass. Then we have the spring balance as well. We have the spring balance for also measurements. For measurements, we have the spring balance for measurements. So hopefully, let's stop here for now as we continue in the next chapter. So in summary, we have looked at few things now. We have considered a few things. In summary, we have looked at the definition of physics, that physics deals with matter and energy and the relation between them. Talked about units. So we have the fundamental units and we have the derived units. The fundamental unit, basically the length, the mass and the time, while others are derived from this tree. They are derived from this tree. And we said we have the standard units and we've mentioned them. We said for meter, we have for length we have meter, for mass we have kilogram, and for time we have seconds. For these are standard units. And we went further to look at some derived, some other units of standard derived units. Standard derived units. We looked at length, we looked at mass, we looked at time, and some other fundamental units we've mentioned. And we looked at some measuring instruments for both the mass, the length, and time. Thank you.